Akula SSN Project 971 Subbrief. Written and read by Amick. Chapter 1. Alright, so our story begins in July 1976 at the Malachite Design Bureau. This is the submarine design bureau that does a lot of the Russian submarines. We've talked about this design bureau in just about every submarine lecture, and sure enough, they're involved in this one. So what they're doing in 1976 is they're working on a new class of submarine that hasn't been named yet, but it does have a project number. It's Project 945, and it's going to be a titanium hull fast attack submarine. And so it's very light. They expect it to be very fast. They haven't built it yet. They just have it planned out on paper. When they come up with a great idea, they're like, we could build a lot more of these if we use the same design, but we don't use the titanium hull. We use steel. They're like, that's a great idea. Why don't we do that? So they begin a second project, kind of a sister project, using essentially the same plans, but with different materials. And that's how Project 971 would eventually come to be. That project is also designed in the same building in St. Petersburg, previously known as Leningrad. Leningrad was changed to St. Petersburg. Just a quick historical note, Russia does that a lot, even with the cities we're going to talk about today, with ports and harbors. They change the names of cities. It's very common in their culture to do that, as they do with the submarine names as well. So this design is going to be a two-hull design, single shaft, fast attack. One of its main qualities is the sound isolation techniques that they're implementing. They're implementing two types. This is the first time that they've done this. Pneumatic shock sound isolation and vibration isolation. Those are two different kinds of sound isolation mounts, and they're using them together for the first time. So these submarines are going to be much quieter than the Victors that they had been building up to now. All right, a year later, September 1997, the Shakuka B technical project is approved. This is the code for the steel version of the Sierra. It's also known as Project 971. It's given a project name. It's given a code name. One of the things that this project will be able to do is shoot the Granite cruise missile. They do centralize the command room, so all functions of the submarine can be controlled from one spot in the center of the submarine, right under the sail, basically. It's going to be a command center. The pop-up rescue chamber for the crew is going to be added to this project. The Sierra has it as well, so not necessarily a new thing, but they are keeping it, and it's worth mentioning. The zonal blocks are what they're calling the shock absorbers that are mounted around the ship. And what they are is they're large rubber blocks that whole sections of the submarine or very large equipment like the turbine generators and the main engines will actually be mounted on. They call them zonal blocks. They also use spatial frame structures for deck plate isolation with rubber cords. And so that's more of the vibration isolation right there. These rubber cords aren't springy like you may think of a rubber cord that you hold down your luggage in the back of your truck in. The rubber cords are actually very stiff, and they work in tandem with the zonal blocks to isolate high frequencies, and the zonal blocks will isolate low frequencies, and together all the frequencies of the spectrum are reduced significantly with this twin form of sound silencing. This is all brand new to them. They've never tried this before, but they expect great things, and they are going to be right. So let's talk about powertrain back in the engine room real quick for this project. They have the OK650 Bravo. Over the life of the submarine, they changed the reactor a little bit. They have the OK650M modernization, also known as the VM5. All the reactors have the same amount of power. They're essentially the same design with some minor tweaks that we're not going to get into. It's a 190 megawatt reactor in all cases. They all have 4 steam generators. They produce about 50,000 horsepower, giving the Akula approximately 32 knots. And I've seen that myself. I know 32 knots is their flank speed. 2 turbine generators for AC power, 2 groups of batteries, and 2 motor generators for AC to DC conversion, which is standard. U.S. Navy uses the same thing. Notice how everything is, in twins, because you always have a backup. And then 2 DC powered spinners is the auxiliary propulsion on the back. The Victor series had that as well. And the spinners are used for station keeping, and they can maneuver a little bit better in and out of port if the tugs need assistance. But what we've seen with the
Sample complete. Ready to continue?